start my recording right there. So we're looking at number 1, and the student says it's D. And they say it's D because they looked here where there should be a 2 pi. And they know that they appeared to have divided by 2 everywhere, which is what you would do if there was a 2 there. So I agree. Number 1 is D. All right, let's pull out a random kid. Ian Owens, what do you say about number 2? And tell me why E feels right to you. Describe a feature of E. I think you're right. Just okay.
I was looking at the wrong one.
All right. So E is an elephant. What's the feature that makes you think it's probably right?
The amplitude.
The amplitude. So how high the wave went, and it went up to 3 instead of 1. And that's this right here. So I agree. Number 2 is E is an elephant. Number 3. Let's go with Lisa.
I said F.
Tell me why F feels right to you.
Because we have 3x and we divide everything by 3. That's the only one with higher degrees.
Oh, interesting. Okay. So even though normally cosine would end at 2 pi, this is where it would end. Yep. And normally it would end at 2 pi. It's been 2 pi over 3, which matches up with this 3 right here. I agree. Number 4, Hannah K.
I thought it was A because.
Why does A feel right for number 4?
Because it was flipped.
All right. So you knew that sine would normally be like this. And you saw that as being flipped. All right, good. That seems right to me. How about number 5, Nick Griffin?
I said C.
Tell me why C feels right for number 5. Okay. And the other thing, sine would normally be going like this, right?
Yeah.
So not only the amplitude of a half, but it's flipped. Yes, I think I could hear you say that. On to number 6. Let's go with Badeau. Obviously, process of elimination could probably do this, but which did you think it was? All right, B as in banana. So that is the only one left. That's a good reason, but also, how could you judge it?
Because of the X values.
Okay, if we look at the X values, normally what would be right there? For normal cosine, what would be right there? Pi over 2 would normally be right there. And what did they do based on this?
It's like twice that.
All right, they multiplied it by 2, and that gives you pi, and that works. Okay, good job. All right, so this is just plain old-fashioned graph. Everybody, try number 7 right now. It's got labels in there. If you zoom in, you'll see there's some nice labeling in there. Now, that might actually be mildly annoying to you because, like, you'd like cosine to finish at 2 pi. If you want, you can just put on another couple marks and have it finish right there. That's where 2 pi would be. Evie Ingebrigtsen, can you tell me, how did you start on the y-axis? Where did you pick to be 1?
I just did the first block up as 1.
Okay, so you called this spot right there to be 1. I'm curious, in the classroom, how many of you chose that same spot to be 1? Just one block up, that was 1. All right. How many of you went higher than that? Raise your hand if you went higher than that. Okay. And it's totally fine to do that, just so you know. Okay, so you can define it and say, I want that to be 1. You can do that. All right, but since it seems like about half the class did it this way, then I'm going to graph regular cosine, and I'm going to do it in 4 parts. First part, second part, third part, fourth part. That's a good start because that's generally what cosine looks like. Henry Remick, tell me how to adjust it from there. All right, here's the flip it upside down part. My same 4 parts. Okay, cool. Now it's the blue one. And then move it where? Yeah, everything moves up 3. So then I go up here. I'm taking all of the dots and moving them up 3. All of the main parts. There. Okay. So some of the points you could check to make sure you had it right. If you had the point pi over 2 comma 3, that's this point right here, then you were doing it right. That should be 2 and this would be 3. Because that one used to be pi over 2 comma 0, got moved up 3. All right, now there's obviously a lot more graphs that we can do here, and there's different ones like secant and sine, and but what else do you have to know for this upcoming test? One of the most important moments. Oh, there's a hand up. Question.
On the last problem,
Yep.
if this were the test and those are the only directions that we were given, would we have to graph the entire graph or just one period?
Good question. You can default to 1 period of the function unless otherwise told. So yeah, one period of that would have been fine. I know down here, is there I thought I saw somewhere on this worksheet. Was there a spot where it said like graph this between here and here? Maybe that's not on this worksheet. I'm thinking of something else. But good point. Doesn't have any other directions to the contrary, so just 1 period was fine. All right, so let's make sure that you get the lab. Why don't you pick a city in Ecuador? Francis.
Because it's close to the equator.
And therefore, what happens with your wave?
I forgot what specifically, but like it messes with the amplitude.
Very good. And basically, it means your amplitude would be pretty much just 1. Like it wouldn't be much more in the summer and less in the winter and whatever. Okay, so sunlight might be more interesting to just do right here in Minneapolis. So again, you look up some numbers and you get a low spot and a high spot. Okay, now I don't want to do the lab. I already did one. If you want to see a video like that, I already have one. But I'm going to give you a different scenario. Okay, this is going to be a population of. Have you guys heard of cicadas? They're a bug that comes out and they have this crazy cycle like every 17 years. And yet they come out in Fibonacci numbers always, which is kind of cool. And like they might hatch, and then that they lay their eggs, and their eggs won't hatch for like 12 or 13 years. It's just crazy. And then all of a sudden there'll be this huge group, and then there's this other group that maybe is the next year, and they end up never never is a big word, almost never hatching at the same time as another big hatch. Or do they always hatch together? Well, there's something like amazing about how their hatches work out so that it tends to make their species survive longer. Okay, so we're going to talk about how many cicadas there are. And let's say on day 100, there is our low spot. We're counting, we do this like survey thing, we're looking in trees and we're listening for them. And let's say that there's only 40 of them present on day 100. Okay, let's say on day 200, we'll keep it simple. The highest that we see is 400 cicadas on day 200. And let's say that cicadas were something that cycled from low to high, back to low, back to high. They aren't that simple, but if they were, we could write a sine or cosine function. So let's kind of talk this through. So what would be the function that we would use? Molly Geldert? Yeah, you would use cosine. Why is cosine easier for these?
I think it's easier to like shift it.
Yes, the shift is easier. You are correct. So here's our low spot, here's our high spot, and I like to draw a curve that kind of goes through them just to kind of be able to visualize it. I think one of the reasons that taking notes increases your chances of remembering stuff is that you see it on the page. And our visual memories are much better than our memories for audio. If I challenged you with this, think back to a movie scene. But a lot of you could pull up a movie scene in your head. But are you pulling up the audio track that goes with it? Do you get what I'm saying? I bet you don't have the audio track, but I bet you can see it. So we're much better at visual memory. I'll try to teach you a little bit about yourself through this class. At least what I have learned. All right, so I want a number for this. To do that, I need this. What's the name for that dotted line? Megan Ishii? I agree. And can you tell me how I would find the midline in this case?
You have to go between the y values, so between 40 and 400.
All right. Why are you picking the y values? You are correct, but let's say somebody said, I thought it was the 100 and the 200.
Because the midline is a y equals.
Very good. The midline, since it's horizontal, would be a y equals line. Okay. What is it, by the way? Well, you average 40 and 400. How do you average two numbers like that? Nick Griffin, how would you average those?
You just add them up and multiply by 2.
Good. So this adds up to 440. So what's the answer?
Oh, 220.
Yeah, 220. Trying to make it work nice. So is 220 what I put in here in the box? No. Joey Gasser, can you tell me what to do with my 220 midline? Goes somewhere.
We need a plus 220.
Yeah, at the end. There's a plus 220 at the end. We got other things to do. We got something in front of this. We got an x minus, and I'll make them different colors. We'll make this one blue, and I'll make this one black. We still have to figure out the red box, the black box, and the blue box. We can do another one now. Aiden, can you help me do another one of these boxes based on the 220? The 220 helps me find one of the others. I'll give you a hint. You typically do the last part of the equation, and then you go do the first part of the equation.
Can you use it to find the amplitude then?
Yes, you can. So tell me how you would use the 220 in finding the amplitude.
Subtract the height from 20.
All right, so 220 and the 400, is that something you could do in your head?
180
I agree. Where should that go?
in the very front.
Yep. 180 is our amplitude. And that was this. It's the distance from midline up. All right. Navi, I think you're pretty smart, so I think you can probably handle this. It's one of the tougher things. This blue box, how do I do that?
You first have to find the period, so since you only have half the graph kind of drawn right now,
Mm-hmm.
you would take the 100 in between each of those 2 points and multiply that by 2.
All right, so between 100 and 200, you're saying that that distance is 100. I'm not repeating because you said it badly. It's because the kids at home can't hear you. So it's 100 to get there, but why did you double it?
Because we only have half of the cosine graph.
Yeah, we only have half the graph. It's only gone up. And it has to come all the way back down to complete a period or a cycle. All right, so It's 100 to get from day 100 to 200. It's 100 right here, but then we have to double it, so 200 is our period. Now what? Let's have, you're good, but let's have Grace Wander take this one over. Yeah, we're doing period is equal to, what is period equal to anyways? I mean, it's 200, but I'm trying to fill in this right here. You are correct, 2 pi over b. Okay, so now 200 equals 2 pi over b. And so now, I don't know if you guys have learned this yet, but these two can just switch. At first, when somebody told me that, I was kind of annoyed because I'd rather like show my work, multiply both sides by b, but it actually works pretty well. There's no math like law that says that, but if you do enough of them, you'll realize that that is true. You multiply both sides by b and you divide both sides by 200. Anyway, there's my answer. It's b. Why am I not going to write 2 pi over 200 in there? Sarah Johnson. Yes, to what? Pi over 100. Very nice. Now, toughest question I'm going to ask all of you, and I make all of you think about this. Oh, wait. Go ahead. Thank you. Pi over 100 is supposed to go here. You are correct. The shift. How, if I call on you to do the shift, how are you going to explain it to me? I know what the answer is, but how are you going to explain the shift to me? Everybody think about that. Andrew Hermanson, are you here today? I thought I remembered to mark him absent, but I put the wrong symbol in the thingy, so I'll fix that. Okay, Lisa, can you tell me? How do I do the shift?
I'm not exactly.
Okay, I'm going to give you a hint. If I made my graph like y-axis, I can make it anywhere. Let's say I make it like somewhere way over here. And I'm going to draw a line in. I'll make it nice and dark. Let's say it's there. Well, shouldn't cosine have its peak right on the y-axis? But it doesn't. It's over that far. So how far over is that? It's the x value of that. So that's over 200. It's the x value of the first peak. Now, there is other ways you can do this. I want you to think, use that giant brain of yours. Couldn't I go even further over and I would have got another peak of this graph? If one of them's here, but wouldn't there be another peak coming up over there? What would the next number be?
Would it be 400?
It would. All right. And if this is truly shifted 200 over from where it started, then wasn't the beginning of it actually a peak? Do you get what I'm saying? If the period's really 200, wouldn't there be another peak right there? And that means we could put 200 here. It isn't wrong. We could also put 400 there, but there's a third thing we could put there. Nothing. I could put 0 there because this one happens to start with a peak. And it's still, you could argue, it's the x value of the first peak. What is the x value of the first peak? 0. So you could put a 0 there too. Does that always work? No, it only works when cosine happens to be right at the peak when you start. Okay, so I feel like that's a decent enough review for today. we're in kind of a weird spot where the test could have been tomorrow, but tomorrow's a weird short day with the and this is going to be a hardish test. We knew that just giving you this test, especially in a pandemic with a giant worldwide jury trial going on, we didn't want to plan for it to squeeze it all in on a short day. Bad idea. So, what does that mean? That means you have homework for tonight. Just finish this worksheet off. I started it with you. The rest of it's your worksheet. It's your homework. Okay, so finish that off. Drop it in the Dropbox. That will be provided. It's not there yet, but it will be. And I do want to end. I'm going to end the video here, but I'm going to end with something I call a math behind it.